So this is the session where we'll talk about improving performance and availability of your internet-facing workloads using AWS Global Accelerator. So if you're a network architect or a network engineer or a site reliability engineer or perhaps an application developer, application owner responsible for running your internet-facing applications, you perhaps grappled with the problems of internet weather. So you run your application on US East 1, and you suddenly see much higher variations in performance and availability for your users in Singapore or Europe, or even on the East Coast compared to those users who are much closer to US East 1. So I'm here to talk about how to improve performance, availability, and security for your internet-facing applications all over the globe using Global Accelerator. This is a 300-level session where we'll progressively go deeper into the topics. Hi, my name is Ananda Rajagopal, and I lead product management for Global Accelerator and internet monitoring at AWS. So here's what you can expect in the next hour. We will go through a quick recap and refresher on Global Accelerator, very brief, promise. We'll also talk about multi-region deployments and how to improve availability. Now, a lot of folks, when they think about Global Accelerator, think about performance benefits. After all, the name suggests a performance benefit. But not everybody thinks about Global Accelerator as a DDoS protector. So we'll talk about some of the DDoS protection capabilities that you get with Global Accelerator. We'll talk about an exciting case study of Okta's journey with Global Accelerator, and then I'll wrap it up with some new capabilities that we've introduced this year and some deployment best practices. We should have some time for a live Q&A, so keep your questions ready. Now, I know that many of you are already experts on Global Accelerator since this is a 300-level session, but just to level set, I promise to do a very quick refresher on Global Accelerator. So when we speak to customers like you who are deploying internet-facing applications, there are a few common themes that emerge. You want to offer a predictable end-user internet experience to all of your users. You want to deliver your workload that is running in one region, such as US East 1, to a global user base that could be located anywhere from New York to San Francisco to Singapore or Adelaide. And as you begin to scale your application, you want to move from that single region deployment in US East 1 to perhaps a multi-region deployment and still maintain that simplicity in traffic management. And as you're doing all this, you continue to keep security top of mind because that is so critical for your business. Now, all of these are very common patterns that we find across customers. So Global Accelerator allows you to overcome the impact of internet weather by carrying your end-user traffic on the Amazon global network as opposed to being subject to the vagaries of the public internet. This is a networking service that offers global static IP addresses combined with the power of Anycast. So we advertise these route prefixes across all of our border locations, across all of our transit centers around the world. And these IPs then become the fixed entry points for your applications that could be in front of an application load balancer or a network load balancer or an elastic IP or EC2 instances running in region. Speaking of IP, if you choose, you can also bring your own IPv4 prefixes, or you can just use the Amazon-provided IPv4 addresses. By the way, this is not CloudFront. This is not a CDN. It's not a caching service. It's a layer 4 Anycast service that can work with any TCP or UDP workload, including your HTTP, HTTPS, quick workloads, can also be any RTP workload or anything that's TCP or UDP. Now, when you're deploying in multiple regions, you want to have the power to route traffic to endpoints in the closest region. So for example, maybe your traffic from all your users in Brazil goes to the Sao Paulo region, whereas all of your North American end users continues to go to the endpoint that you have in US East 1. The other key benefit here is the ability to do fast failover across endpoints without relying on DNS, because DNS caching by your end users, by the clients, the browsers, is not necessarily a good thing. And lastly, in combination with In combination with AWS Shield or Shield Advanced, Global Accelerator protects your traffic from volumetric and protocol attacks at the edge and as close as possible to the source. Global Accelerator lets your end user traffic to communicate with your applications over the Amazon Global Network instead of the public internet. And the way this is done is that your end user traffic enters the Amazon Global Network at multiple edge locations. These are called as points of presence, or POPs for short, that I'll keep using through the rest of this session. We have 104 POPs located across the world today that are spread across 88 cities and 48 countries. This year alone, we've added 8 new POPs. That includes POPs in 2 new countries, Oman and Vietnam. You can think of these POPs as the connection points into the congestion-free Amazon Global Network. So every time we add a new POP, we're effectively taking your application closer to end users that are in that vicinity of that metro. Now let's start diving deeper. So the AWS Global Network is a high bandwidth, congestion-free network that is used for inter-region traffic, CloudFront origin fetches, and also by Global Accelerator. The network is built with multiple redundant 400 gig links, with each edge POP having multiple links to the backbone, and each edge POP having multiple paths to the region. Furthermore, AWS uses automation to maximize the resiliency. So we monitor our network and the public internet routes to diagnose issues rapidly and prevent any issues from affecting your applications. In fact, we make over 3 million changes a week to optimize the traffic. The implication is that we can avoid congestion and outages before your applications are impacted. And with millions of devices offering hundreds of data points every single second, AWS is literally analyzing billions of data points, correlating, discovering, and solving these reliability issues proactively. So because of this, as a Global Accelerator customer, you also get to enjoy lower latency and jitter compared to the public internet. So this chart here shows the P95 first byte latency from client locations in the United States to endpoints in Dublin, Ireland. And this is done over a 15-day period. Measurements were taken earlier this month. The red line here shows the latency using public internet, or the impact of internet weather, as we called it. And the blue line shows the corresponding measurements with Global Accelerator. So the 2 noteworthy things about this chart. The first is that the latency reduction is quite significant. That actually translates to about 120 milliseconds at P95, or almost a 40% reduction in latency for this specific traffic profile. The second noteworthy thing here that stands out is notice the much lower jitter compared to the public internet when you're using Global Accelerator. And this is something that's pretty typical for a lot of traffic profiles. The performance benefits that we deliver are partly because of the congestion-free Amazon Global Network, and partly because of the optimizations that we do, such as TCP termination at the edge. So without Global Accelerator, TCP session traffic that is initiated by your end users has to travel the distance all the way to your regional endpoint. So let's say you got your users in San Francisco, and you're running your application in Northern Virginia, US East 1. That is about 2,800 miles. So your TCP SYN packets flowing from the end user, the SYN-ACK responses, the ACK response, each of these is traveling the distance of 2,800 miles each time. Naturally, that leads to lower performance. With Global Accelerator, we actually implement a function called TCP termination at the edge, which is effectively a TCP proxy. So what happens is that when your end user initiates a TCP connection, Global Accelerator responds with the SYN-ACK from the edge POP and simultaneously opens up a new connection to the regional endpoint. And because of this, and remember, by the way, that your San Francisco users in that example are much closer to the edge POP. So the edge POPs are distributed around the world. So the edge POP is only about a few miles away from your San Francisco user, whereas the distance that you're going over the congestion-free Amazon network is much larger. So that's what leads to that improvement that you see in the first byte latency. Now, this is really valuable for a large class of TCP workloads. And in particular, think about your highly interactive workloads that have got a high number of requests per second, API workloads, for example, and they can really benefit from this optimization that we do at the edge. The benefits are more than just an improvement in first byte latency. It actually translates to an improvement in throughput as well. So the TCP termination allows you to get up to 60% improvement in throughput. And one way to think about this is there is a narrow, short network between the end user and the global accelerator edge location, and a wide, long network between the global accelerator edge location and your regional endpoint. This enables us to tune the parameters separately for the TCP parameters separately for both connections to overcome the bandwidth and latency limitations. For example, some of the optimizations that we do are disabling TCP slow start, using jumbo frames to pack up to 6 times more payload into the connection between the edge location and your regional endpoint, having larger receive size windows, larger TCP buffers. And overall, what you can expect is that for traffic in the same continent, there's a benefit of up to 40%, and cross-continent traffic, generally, there's a performance benefit of up to, throughput benefit of up to 60%. To date, over 20,000 customers have successfully deployed Global Accelerator for a variety of highly interactive workloads. And these span a broad range of industries from financial services, ad tech, media and entertainment, software and internet, telecommunications, and many more. We are really inspired by the innovation that these customers are able to deliver to their business using Global Accelerator. Later on today, I'll speak about Okta's journey to Global Accelerator this year. Let's also see how some of these customers, what they have to say. So Vercel is a leading cloud platform for front-end developers, and they've been able to innovate for their customers by leveraging Global Accelerator for their edge network to maintain the ultra-low latency while serving millions of domains and billions of requests per day. So many thanks to Steve and to the Vercel team for your partnership here. Another example is NodeReal, a Series A startup that offers blockchain API services for their customers. And as Henry Liu, their CEO, says, using Global Accelerator has allowed NodeReal to provide these services with high resiliency and low latency. Thank you, Henry, to you and to the NodeReal team for your partnership here. At Amazon, several key services and products are built on Global Accelerator for part of their functionality. For example, Elastic Container Registry uses Global Accelerator for ECR Public. When you connect to the AWS Management Console, your session traffic is actually being accelerated by Global Accelerator. In fact, CloudFront uses Global Accelerator for TinyDNS on EC2. Last year, you may recall, we announced S3 multi-region access point. So this provides a single global endpoint to access a data set that spans multiple S3 buckets in different regions. Chime SDK uses Global Accelerator. If you're using VPN, site-to-site VPN, you have an option for acceleration that actually makes use of Global Accelerator. And in gaming, Amazon New World recently onboarded the Global Accelerator. Now, I don't know about you, but for me, my first non-human interaction every day is with Alexa. And I'm pleased to share today that Amazon Alexa has also recently onboarded to Global Accelerator for traffic from certain countries. So since onboarding, the Alexa team has observed a whopping 17% drop in user-perceived network latency. So if you notice Alexa being a wee bit faster when you ask questions such as, Alexa, what happened to the recent World Cup game between Uruguay and Portugal? The answer is Portugal won. So you know why the Alexa responses are faster now. So each of the examples I've shared in the last few minutes of proof points of the tremendous scale that we deliver with Global Accelerator and also serve our customer needs every day. Now, many of you use Global Accelerator for performance benefits, which is perfectly understandable. But I think there's an equally important benefit of Global Accelerator in simplifying multi-region deployments or building highly available architectures. So if you look at critical workloads, such as dynamic API delivery, gaming, voice over IP or video over IP, or many other enterprise workloads, they have very high resiliency requirements and availability requirements, along with performance. And they often use multi-region architectures in order to accomplish them. So Global Accelerator offers several important capabilities that you could use to simplify the rollout of such multi-region architectures with ease. For example, let us say you want to roll out application changes in a blue-green deployment or perform A/B testing, pretty common scenario here, right? So Global Accelerator offers weighted endpoints that can help you roll out such application changes. So key to this is how Global Accelerator determines health of the endpoints. So Global Accelerator continuously monitors the health of all endpoints in a standard endpoint group and only routes traffic to the healthy endpoints in that endpoint group. So you can use these weights to distribute traffic in a way that matches your application deployment. For EC2 endpoints, you would configure the health checks as part of your accelerator configuration. And for application load balancer and network load balancer endpoints, you would do that as part of the ELB configuration. So one detail to remember here, especially when you're using ELB endpoints with multiple target groups. So Global Accelerator would consider the load balancer endpoint to be healthy only if each target group behind the load balancer has at least one healthy target. So if any target group has got only unhealthy targets, then Global Accelerator considers that load balancer endpoint to be unhealthy. So if you want to upgrade a target behind the top NLB in US West 1, which is the bottom region that you see there, you can do it in two ways. One is you can change the endpoint weight to 0, or you can just set the health of the target to be unhealthy so that traffic no longer is sent to that endpoint. And one of the important things to note here is that as you're doing these changes, your users, end users, don't see any change at all because they're still communicating with the fixed static IPs that are provided by Global Accelerator, right? So that's a huge benefit from the point of view of how you can simplify your application rollouts. Now, what about endpoints in multiple regions? So this is where traffic dials comes into play. When Global Accelerator is provisioned in front of multiple AWS regions, or endpoint groups as we call them, by default, requests are routed to the closest region. So healthy endpoints in the closest region. So let's take the same example where you want to take your application down for maintenance and shift traffic to endpoints in a different region. So you can use traffic dials to accomplish this. You can also change the health of the targets behind the ALB in the region that you wish to upgrade to kind of steer traffic away from them. So for example, when you change the traffic dial to 0, basically you're redirecting traffic away from that region. So when it comes to multi-region failover, you might be asking yourself, well, why not use DNS to accomplish the same thing? And that's a fair question. So let's look at the results of an example that one of our customers observed. So this customer is directing some traffic to Global Accelerator, which you see represented by the orange line, and some traffic to a public ALB over the public internet that you see represented by the green line. And this was in steady state, and the customer wanted to trigger the failover from endpoints in one region to the other. So as you can see from the chart, with Global Accelerator, the customer was able to failover almost 500,000 connections in less than 4 minutes, as opposed to that long tail of almost 6 hours that it took to drain all the connections when going over the public internet. And the reason is because of DNS caching, right? So that's something that you as an application owner really cannot control. So this is another really important benefit of Global Accelerator, where you can achieve faster failover compared to DNS, without requiring a control plane update too. So the failover to the healthy endpoints is managed by the Global Accelerator control plane, and this is very useful when you want to eliminate the effects of DNS caching. Okay, let's talk about availability. So Global Accelerator is designed for 99.995% availability. So I'll do a deep dive now to help you understand some of the high availability architectural aspects of Global Accelerator that you get as a customer of Global Accelerator. But first, some data points. According to Cisco Thousand Eyes, there are 190 more global internet service provider events that happen every week. This was measurements that were done over a one-year period between September of last year and August of this year. Furthermore, Cisco Thousand Eyes also analyzed all network events around the globe over a one-year period. And this is in this recent performance report that was published earlier this month. And they found that 89% of all network events were traced to either internet providers or transit providers. So it's clear that cloud provider networks have a higher availability. Recall how the Amazon Global Network, for example, provides that congestion-free network and that automated auditing that helps provide that superior availability and superior network experience. So what does all this mean for you as an application owner and also for your end users? So accessing your application in AWS is not this simple. End user, internet, and your application in AWS, right? So it can take many networks to reach your application. The paths to and fro from your application may not be the same. Each one introduces different availability characteristics, different additional latency, and the net effect is what we call as internet weather, which means there is less determinism in both performance and availability. So Global Accelerator helps reduce the impact of internet weather because your end user traffic is traversing the third-party network over a much smaller duration and over the Amazon network for most of the duration there. So the resulting availability and performance of your application in the eyes of your end user improves. So Global Accelerator is built, as I mentioned, for 99.995% availability when both IP addresses of the accelerator are used. So what's the big deal, you may ask, of 99.995% availability versus, say, 99.9% availability? Well, the difference happens to be almost 500 additional uptime minutes every year. So when your application is really critical for your business, every minute of uptime matters, and that's why we have architected availability into every component of the Global Accelerator service. So this begs the question, why is it so difficult to get availability right on the public internet? So as our CTO, Werner Vogels, has famously said, everything fails all the time. So customer availability is impacted by the infrastructure on which the application is run on. And Global Accelerator is built not only in the most available cloud infrastructure, but also we've taken care of those corner case situations, or sharp edges as one may call, to make sure that the data plane availability goal is met. So in the event of failure of any of these components, we have put measures in place to quickly recover from them. And bear in mind that building a highly available Anycast service is not easy because there are lots of factors beyond one's control. I mean, here are just some examples here of potential impairments that could happen, right? Local ISP issues, or something happening at the edge point of presence, or maybe an entire POP getting isolated from a backbone. So we've accounted for each of these scenarios and many more so that you don't need to worry about them and can just deliver your application with confidence using Global Accelerator. So let's look beneath the hood in terms of some of the measures that we've taken into account of these various stress points in Global Accelerator. So first off, our edge points of presence are connected to the internet via our border network at our transit centers. This is where Global Accelerator peers with external networks, i.e. the autonomous systems, or what is popularly called in networking lingo as ASNs. traffic from these ASNs traverses a border network before it is processed by the global accelerator stack. Within each edge POP, we have two completely independent network zones. Both these network zones are used for each accelerator. So of those two IP addresses that are assigned to your accelerator, each of them are assigned to two different network zones. You can think of the network zone as conceptually analogous to the concept of availability zone that you're already familiar with in regions. Each network zone has got 4 cells. Each cell has got multiple hosts. The failure of one host in a cell does not impact any other hosts in that cell. So this cellular architecture means that the blast radius is heavily contained whenever any failure happens. Next, we also use something called as shuffle sharding. So sharding is the process of slicing up the infrastructure and then allocating it to different customers for their use cases. So with standard sharding, customers are effectively divided into groups and associated with a piece of the infrastructure. With shuffle sharding, you're kind of improving upon that by basically creating a virtual shard and then putting each customer into more than one shard. And then, of course, the virtual shard is mapped into the underlying resources. So in this example here, what you see here is 3 customers. We're calling them as customers 1, 2, and 3. You see that customers 1 and 2 are mapped to cell A in the network zone on the left, and the network zone on the right, you see that they're mapped to 2 different cells, right? So again, ways in terms of how we minimize the noisy neighbor problem here. By the way, this is also the reason why we always recommend that you use both IP addresses of your accelerator, not only for resiliency reasons, but also it doubles the capacity, right? There's more resources that you have available for your accelerator when you use both IPs on each edge POP. Now, because Global Accelerator is an Anycast service, the prefixes are announced from multiple POPs around the world. So all of those 104 POPs that we talked about, through the associated transit centers that we have. So let's say your clients are connected to multiple ISP networks, and user traffic follows the shortest path from the ISP to the nearest edge POP. So if one of the ISP networks is impaired, then the BGP routes get withdrawn from the transit center of the affected POP, and then effectively the end user's ISP routes the traffic to the next closest edge POP. So this is kind of the built-in resiliency that Anycast offers. The same also holds true in the extremely rare case when an entire POP goes offline. So as mentioned before, with respect to route advertisements, we announce these prefixes from every Global Accelerator edge POP through our transit centers. And until recently, we ran the BGP speakers in each edge POP. See those icons there that are in those edge locations. Now, each edge POP has at least 2 independent links to the backbone. But you've got to ask the question, what happens if all the links connecting the edge POP to the backbone fail? In that case, the POP would become isolated from the backbone and the AWS regions. So that has to be as quickly as possible rectified so that traffic from your end users is not getting black holed. Now, can this happen? Yeah, it can. So for example, imagine an overly eager construction worker who starts cutting through and digging through a critical network path that suddenly cuts off that POP. Or maybe it is an unfortunate hurricane or a tsunami that is actually taking out the undersea cables that connect the POP to the AWS backbone. Those things are rare, but are very plausible. So the service needs to handle this. And when this happens, the clients connected to the isolated POP would see a loss in availability of your application. So historically, we addressed this by using an out-of-band channel to withdraw the BGP routes from the edge location via an out-of-band channel. So in looking at this more closely, we saw an opportunity to innovate. And so this year, we did something even better so that availability could be further maximized. We have now moved the BGP speakers from the edge location into region. And so we now have redundant BGP speakers running in multiple AWS regions. And the route controller that manages these prefixes automatically detects a loss in backbone connectivity, and when that happens, make sure that the BGP routes are withdrawn, and then any cache redundancy kicks in, and as you can see, the client traffic gets sent to the next nearest POP. Again, you don't need to do anything about this. It's just a capability that you get with faster recovery because of this capability. The whole recovery, by the way, from the point of detection of the failure to recovery, that happens in less than 3 minutes now. Global Accelerator also has several built-in DDoS protections that are offered as part of the service. So this is a really important attribute of the service because in combination with AWS Shield, it helps to mitigate those DDoS attacks closer to the source. One of the benefits of Anycast is the resiliency aspect of it, but an equally important one is Anycast offers a much surface area and capacity to absorb DDoS attacks. So these DDoS attacks are mitigated as close as possible to the source and at the edge of the Amazon network. By the way, also notice that with Global Accelerator, you can place your endpoints in private subnets, so your endpoints are not actually being exposed to, need not be exposed to a public subnet. There are two types of protections here. Layer 3, 4 DDoS protections that you get automatically with Shield. And then you can also get layer 7 DDoS protections when you're using it with AWS WAF and specifically with application load balancer endpoints. Also, you can get advanced protections if you're a Shield Advanced customer. So that includes options for things like custom mitigations, 24/7 access to a Shield response team, options for always-on mitigations, as well as cost protections in terms of any kind of scaling charges resulting from DDoS-related usage spikes on the protected resources. By the way, when it comes to the Shield response team, that's the same team of experts that also protects Amazon.com. Now, speaking of protected resources, Global Accelerator is a protected resource for Shield. So that means as a Global Accelerator customer, every single Global Accelerator customer gets the benefit of those protections from Shield. You apply these protections at the edge so that you're effectively creating less congestion on your regional endpoints and creating more mitigation capacity as well. The mitigations are placed close to the edge, but in addition to that, Global Accelerator also has other safeguards in place that includes rate limiters at the edge, making sure that there are accelerator-specific limits to avoid resource overconsumption. Also, only the listener traffic is admitted at the edge, and everything else gets dropped right at the edge. Other benefits include protection from volumetric and protocol attacks. So standard mechanisms such as UDP flood protection, ICMP flood protection, malformed packets, spoof packets, UDP deflection attacks, any kind of reset flood attack or ACK flood attack, SYN flood attacks, all of those things are kind of part of the protocol attack protections that you get with Global Accelerator. So when you look at SYN flood protection, so that's done using a mechanism called SYN proxy, which is a stateless SYN proxy that is implemented as part of the service. So when a SYN flood is detected, Global Accelerator responds with a SYN cookie challenge as part of the SYN ACK response. And then legitimate clients would respond to the SYN cookie challenge, and Global Accelerator only forwards the fully validated connections over to the regional endpoints. So effectively, your regional endpoints are protected from SYN flood attacks automatically. Our customers also ask us about layer 7 DDoS protections. So this is to protect against application layer attacks on customer applications. So this is where you can use AWS Web Application Firewall or WAF in combination with application load balancer endpoints. This is a capability we've supported for many years. You can block or count requests meeting criteria, attach web ACLs, rules and rule groups can be attached to AWS WAF. You can also limit application access by origin IP or by origin country, attach regular expressions, limit by request size, and many more. Some of our customers also ask us about layer 7 DDoS protections when they're using EC2 endpoints. So today I'm pleased to share an example reference architecture with our partner F5. So in this architecture, you would deploy F5 Big IP or Nginx Plus running on EC2 instances behind Global Accelerator. Now, both these F5 products have the ability to do signature and behavioral WAF and provide layer 7 volumetric DOS protections. So this is really useful in migration scenarios. Let's say you're used to a third-party proxy running on EC2. You're migrating a workload, for example, from on-premises to AWS. You want to use that third-party proxy. Or even if it's not a migration scenario, when you have a preference for a third-party proxy running on EC2, you can use this in combination with Global Accelerator. So do check out this QR code on this reference architecture. It'll take you to a community blog on the F5 Dev Central, and we'll soon be publishing a blog on this as well with more details. So let's look at one of our customers, Okta, and how they planned the journey to Global Accelerator. So I've really loved the collaboration with Okta and the meticulousness with which they planned their upgrade and migration to Global Accelerator. So I think most of you are already familiar with Okta, but they are, in case you're not aware, they are a provider of identity services to over 16,400 businesses. So if you take a trip to the grocery store or the mall or just interact with your mobile phone, chances are that you're interacting with a brand that trusts Okta. So our point of interaction was with the site reliability engineering team, and for the SRE team, service uptime was the singular #1 focus. So Okta had multiple data points that on their edge that they had collected, and they saw a great opportunity this year to migrate to Global Accelerator, and in the process improve their edge resiliency. So a little bit of context about Okta's edge. So many of Okta's customers are in regulated or compliance-based environments, and one of the requirements is that they must have very tight allow listing policies as part of the firewall rules. So as a result, Okta must have public static IPs so that the customers can allow list a very limited number of those public static IPs in their firewall policies. So prior to deploying Global Accelerator, Okta deployed internet-facing public network load balancers in primary and secondary regions. And so with 3 availability zones in each region, that basically meant 6 IP addresses that had to be allow listed by each of the customers. Now post-migration, as you can see from the picture on the right, Global Accelerator provides 2 static IPs, and those are the static IPs that their customers now need to allow list. The other benefit is that right now it's primary and secondary regions. If Okta in future decides to expand their backend to multiple regions, nothing changes at the front end. Their customers continue to use those 2 IP addresses. So one of the compelling trigger points for Okta was an event in summer of 2020, where there was a major ISP event which affected their production deployment. So this environment uses the Sydney region as the primary and the Singapore region as the secondary region. So both customers and the synthetics that monitor Okta's front door started reporting unavailability of the services during the event. Most importantly, other regions outside this area did not see this issue. In fact, Okta's engineers in Sydney were able to replicate this issue. So during the incident, the deployment in the secondary region was also affected. And so the Okta team spun up a Global Accelerator endpoint, and they were able to register services and restore availability of the service. And as a result, the synthetics returned to the healthy state. So this was a really important data point for Okta because it gave them a data point that perhaps reducing the reliance on external network services, on external network dependencies, would actually increase the availability of their service. So they saw the value of placing the edge closer to their customers, which is how some of the investigations in terms of what part of the edge portfolio of Amazon, of AWS to adopt. So how did Okta manage the migration? So making an edge change can be pretty tricky because you cannot see your customers' configuration or issues if they cannot reach you, right? So Okta decided early on that they would deploy dedicated backend infrastructure for the entire rollout for two reasons. The first one is to avoid something called as connection collisions. This is a topic that we'll cover later. They also needed to simplify visibility for their customers' traffic as to whether customers are traversing Global Accelerator or are customers going over the public internet. So Okta used DNS weight-based routing to move traffic to Global Accelerator. So here's how they did it. To help mitigate the overall impact for the customers, they introduced the new IPs for Global Accelerator over a 3-day period. And because there are multiple production environments, they did this one production environment at a time. So the first day, they would introduce Global Accelerator for about 25% of the traffic, while the remaining 75% continue to flow over the public internet to the public NLBs. The second day, they would introduce Global Accelerator for 40% of the requests, while the remaining 60% continue to go to the public NLB IPs. In the final day, they introduced Global Accelerator for 100% of the customer requests. So with over 16,400 customers, Okta has a range of customers that they serve, and their needs vary. So Okta proactively reached out to the customers to notify them about the migration to the new IPs. So I really loved the collaboration with the Okta team. And while they couldn't join us with me today to be on stage, we are super happy that they've been able to offer a highly available service to their customers using Global Accelerator. So big thanks to Calvin and the Okta team for their collaboration, and kudos on the successful migration here. While we love to see our customers use our current capabilities, we're also continuing to innovate. And so I want to recap a couple of key new capabilities that we introduced this year. This year we introduced dual stack accelerators, bringing IPv6 to AWS Global Accelerator. And this is specifically for ALB endpoints. So with this feature, you now get 2 global static IPv6 addresses in addition to those 2 global static IPv4 addresses. This will allow you to serve both IPv4 and IPv6 traffic through Global Accelerator to your ALB endpoints. And yes, your existing accelerators can also be upgraded to dual stack accelerators even as you retain those allocated static IPv4 addresses. The other capability that we added was to add and delete endpoints with 2 new API calls called add endpoints and remove endpoints. So basically, you can specify a set of endpoints now to add to an endpoint group or to delete from an endpoint group, as opposed to the previous method where you had to provide the full list of endpoints. So up to 10 endpoints can be specified in either of these calls. An interesting tidbit is that our engineers also found a reduction in API execution time of over 50% with these 2 new API calls. So I hope you can take advantage of these. Okay, let me wrap it up with some deployment best practices when using Global Accelerator. So the 5 best practices that I'll review here, and these are considerations around connection collisions, TCP keepalives, cross-zone load balancing, ensuring IP address space in your subnets, and also how to use your accelerator IP addresses. So let's first start with connection collisions. So let's say you started your journey with Global Accelerator, you do a POC, you find out that things are looking good, and now you decide to start the migration. And so you come up with something like this. Okay, I have my ALBs in my public subnet anyway, so let me direct some traffic towards the public ALB and then some traffic towards the Global Accelerator. Is this a good idea? Somebody said no. Yeah, we would caution against this because this can potentially create something called as connection collision. So let me explain why. Yes, from a client perspective, they're addressing the Global Accelerator IP address and also the IP address corresponding to the ALB. However, there's a feature that Global Accelerator supports called client IP preservation. So when the application load balancer sees the traffic coming from the global accelerator, it's not seeing the global accelerator's IP, it is actually seeing the client's IP. So from an application load balancer perspective, it appears as if the same source IP, the same destination IP, the same source port, the same destination port and protocol are arriving from two different connections. And that's what causes connection collision. Okay. So this is one scenario where when you have concurrent connections from the same client IP with the same source and destination port, and you're approaching it through both the internet gateway and global accelerator. A second scenario when this can happen is when you have two different accelerators and they both point to the same endpoint, and again you're having the same source port and destination port and using two different accelerators, because again the global accelerator is going to pass through the client IP address and it appears as if it's the same source IP, source port coming in. By the way, this does not happen when you're using two IPs of the same accelerator, because we take care of that as part of the same accelerator. So how do you avoid this? So we have 4 approaches that we suggest. You saw one of them that Okta did that I'll recap again. There's a really nice feature in Global Accelerator called port override. And basically this overrides the listener port used to route traffic to the endpoint. So let's say you have traffic coming in on port 443, you can actually override that and send traffic on 8443, for example, right? So that way your application load balancer is able to discriminate between the two connections that are being received from global accelerator and from the internet gateway. Or if you have the ability to influence the client uses unique destination port numbers on the two paths. You can also disable client IP preservation. I recognize this may not always be a choice, but it is an option. Or as you saw in the journey that Okta did, you can replicate the backend infrastructure, right, for those two paths. And hopefully this is something that's temporary as part of your migration here. So what you see here is two different application load balancers that have been set up, and the backend infrastructure is basically replicated here. So any one of these options will help you to overcome connection collisions. We are specifically calling this out because this sometimes trips up customers in the early part of the journey to Global Accelerator, and you just need to take a little bit of precaution here to make sure that this does not happen. Okay, TCP connection timeouts. So if you have very long-lived connections, then this is something that you want to keep track of. So you may be using keepalives, but if that connection is idle for a long time with absolutely no payload being exchanged, then you may run into connection timeouts. And the reason is because TCP termination that we discussed earlier on, that is enabled by default. So the responses to the keepalives are sent by the edge pop, but we don't actually propagate the keepalives all the way to the regional endpoint. So ensure at least one byte is being exchanged between the client and your regional endpoint. It can be from either side, so as an application owner, you can always trigger that. And this needs to happen within the 340-second idle timer. Other best practices: disable cross-zone load balancing on NLB endpoints. This avoids connection collisions when the source port is the same. A really big one is ensuring sufficient IP address space in your subnet. So Global Accelerator uses certain techniques to transport traffic from the edge pop to the regional endpoint. And so in order to do that, it creates an elastic network interface, an ENI, in your subnet for client IP preservation. So it needs to have at least one IP address that is available per relevant subnet, right? So please make sure that at least one IP address is available, and so that you don't run into this issue. Because if Global Accelerator runs into this issue, then your accelerator configuration will not complete. You'll see that as in pending state. And lastly, as I mentioned before, use both IP addresses of your accelerator. That maximizes data plane availability and also maximizes the capacity that you can have on each edge pop. If you're interested in learning more, try out Global Accelerator if you haven't already done so. You can also run the speed test from different locations to compare Global Accelerator performance to public internet. And it's a good library of blocks. We continually keep updating them with new use cases, new reference architectures, and it's a good one to bookmark. And thank you again for coming today. Please don't forget to fill out the session survey. And we have about 10 minutes. I'm happy to take questions from anybody.